Good day, we are from Group 2, Embedded System and Application Section 1. Today we will talk about line following mobile robot with metal detection. We have 5 members in this group which are Brian, Ivan, Jun-An, Min-Hui and Jin-Wei. First of all, I will introduce about this mobile robot. Its functions follows a path, detects metals nearby. The sensors used are infrared and optical for path. The application includes transportation, inspection, and exploration. It is a two-wheel design. Next, there are 3 problem statements in this project, which are current solutions lacks adaptability, scalability, and real-time responsiveness. The needs for autonomous device to patrol routes and perform object recognition, and absence of low-cost, efficient system for material handling and exploitation tasks. There are 3 objectives in this project. First is to design and implement a line-following mobile robot integrated with metal detection functionality. Second is to incorporate a metal detection system that identifies and counts metallic objects along the robot's path. Last is to display the count of detected metal objects on an LED screen in real time, providing immediate feedback. For project description, the autonomous navigation include IR sensors and smooth movement of mobile robot. Then for metal detection, the sensors will identify the metals and updates count on an OLED screen. Next, for GPOS multitasking, it includes priority trade. Then for power and feeders, the batteries, LEDs, and buzzers will give the feedback. The benefit of this project is robust, versatile, and fully autonomous.
Diagram shows the connections between the components and the Arduino. The two IR line tracking modules are connected to VCC, ground, and A0 pin or A1 pin, respectively. These line tracking modules are used to control the movement of the robot. The OLED is also connected according to its required pins and is used to display the information in real time. There are two 10K ohms resistors used, and both have one terminal connected to the pin 2 of the Arduino. The another terminal of R1 resistor is connected to the G terminal of the IR proximity sensors, and both go to the ground. The V terminal of the IR proximity sensor is connected to the positive terminal of a 9-volt battery, and the negative terminal of the battery is connected to the OR terminal of IR proximity sensor and the another terminal of the R2 resistor. The IR proximity sensor is used to detect the metal when the robot moves. Besides, a motor driver is used to control 2 DC motors. The motor driver is connected by IN1 terminal to pin 3, IN2 terminal to pin 9, IN3 terminal to pin 10, and IN4 terminal to pin 11. The two DC motors are connected to the output terminals of motor driver, out 1 to out 4. The VCC terminal of the motor driver is connected to 5 volt, and SCNSA, SCNSD, GND terminals are connected to the ground. Last, the VS terminal is connected to the positive terminal of a 6-volt battery, and its negative terminal is connected to the ground. In this project, there are several electronic components are used, such as a Maker Uno, which is simplifying Arduino, a Maker driver, which is dual hash bridge motor driver, an IR proximity sensor, an OLED display, and two IR line tracking modules.
For flowchart, the process starts by including necessary libraries for functionalities like motor control, OLED display, and 12C communication. The motor driver is configured with specific pins for controlling 2 motors. Constants for the 12C address and reset pin are defined. Initialization step follow, where the 12C communication begins and its clock is set to 400 kHz. Depending on the reset pin value, the OID display is initialized with or without using the reset pin. The display is clear and introductory messages are shown on the OID screen. For example, hello, we are from group 2. I am Yiloma, then followed by a delay of 5 seconds. The program then sets up multi-threading using chbegin to handle 2 separate threads. So thread 1 handles additional inputs and outputs. It defines constant for a button, piezo buzzer, and infrared sensor for left and right detection. Melodies for starting and stopping are predefined. The program monitors the button state to start operations with a melody. It then checks the state of the infrared sensor for navigation. So continue here. Depending on the sensor readings, the system decides whether to move forward, turn right or left, or stop. These actions are repeated continuously, ensuring dynamic responses to sensor inputs. Then, for trade 2, variables and pin mode are declared for metal detections using a digital pin, which is pin equals to 2. The program continuously checks if the sensor value is low, indicating metal detection. If so, the OLED display is updated to show the count of detected metals, followed by a short sleep of 130 milliseconds.
Hello, my name is Ivan. So here is the program code. First, for the thread one, we have to initialize the button, the pixel, the IR, and then we have to include the IR function for the direction. And for thread two, we have for the OLED and also the metal sensor, and that's it. And here is the RMS assessment for on the left side of serial monitor. You can see the duration one is for the startup, duration for the loop thread one, duration two is the loop for thread one, duration three is the startup for thread two, and also duration four is the loop for thread two. And from the table you can see the period for each of the thread, where the first priority is the ion sensor with period 25, and the secondary priority, the OLED, the proximity or meter sensor is 130 millisecond period. And below is the calculation where for the first thread, the S10, it will equal to its CPU time 0.128 millisecond. Yes, S11 will also be the CPU time since it is the first priority. And so as they are equal, means that it is the final value and it is less than the period 25 millisecond, hence thread 1 is schedulable. Thread 2, for S20, we have to add in both of the CPU time and we get a value of 0.136 millisecond. For the second one, we have to add in both the CPU time, but the first CPU time for the thread 1, we have to multiply it by the previous S20 divided by the first thread period 25. Even though the value is very small, hence we'll round off to 1, meaning that the final value we obtain will also be 0.136 approximate. And so S21 is S22 is equal to S2 final. So it will also be less than 130 millisecond. Hence thread 2 is also schedulable. So here is the time diagram for both of the threads. And so both the threads will first we have to add the CPU time and also the loop. And for the period, I've chosen the smaller one, which is 25. And so as the operating hour time is in the microseconds, both of the threads can operate in each of the section without any problem.
My name is Brian Lau Jiaqing. I will talk about the result and discussion parts. As you can see here, the left side has two pictures, which is the external design of our robots and the internal circuit. So there are some main points for the discussions, which first is the system performance. So the robot will accurately follow the designated path and corrects its trajectory by turning right and turning left. So the robot will be hot and stop melody is played when both sensors lost track of the black line at the same time. As for sensor reading and display, the proximity sensor used to detect the meter operated at a periodic interval of 130 milliseconds, and the count of the detected metal object will be displayed successfully through the OLED display. There are some challenge faced using during this project, which is where the IR sensor the sense require fine tuning and position adjustment to avoid false detection caused by the ambient lighting conditions, and the motor speed variation requires speed adjustment through the coding for optimal performance so that the robot can run smoothly. And is as in conclusions, this robot has performed reliably and had proved effectiveness in achieving the desired objective.